So now we're going to try, rather than regressing using every point on the line, we're going to regress using the point where it crosses the x-axis, because that's the easy one to find, and choose one of the other points on the line and make a regression line from that. So if we choose the first point when x equals 0, we can substitute these values into the equation here that we've already got for a regression line. If we decide that c is 10 for our asymptote, because that's what we said it would be last time, we'll get y equals a e to the k x plus 10. That gives us an asymptote of 10, which seemed reasonable given where it was going down to here. Now we'll put in the y values and the x values. So y is 92.77, a e to the k times 0 plus 10. And we look at this, k times 0 is 0, e to the power 0, well, anything to the power 0 is 1, so it's a times 1 is just a. So we now get 92.77 equals a plus 10. So a equals 92.77 subtract 10, which is actually 82.77. So we found our value of a. And then if we choose one other point here, doesn't matter which one we choose, any point. So if we choose 0.5, for example. In fact, let's do it with just for any point. If I choose any of the y and x value, we'll call them x1 and y1. If I choose x1, y1, which is a point on the curve, I get y1 equals 82.77 e to the k x1 plus 10. And now let's try and find what k is. So subtract 10 for both sides, get 82.77 e to the kx equals y subtract 10. Divide by the 82.77, e to the k x1 equals, that should be y1. y1 subtract 10 over 82.77. We want to get rid of the e to the power to get just this on its own, so we do a log of both sides to get k x1 equals the Neperian log of y subtract 10 over 82.77. And then to get k on its own, we have to divide by x1, so we get k equals 1 over x1, Neperian log of y1 subtract 10 over 82.77, which actually we're going to put it in computer speak. I need to do k equals log of y subtract 10, y1 subtract 10 over 82.77 divided by x1. I don't like doing that, but just so I can put the formula in. And this I can write as this value divided by this value. So what I have to do in a spreadsheet is now to get the a value, take the initial value, subtract the c value. That gives me the a value. And then I can work out the k value with this formula here. It should give me the k value. And I could work that out choosing different x1, y1 at any point here. So for every row, I can put in a calculation of what the k value would be using this first point and one other point on this curve, and it should draw me a curve that goes exactly through this point and this point. So I should get a curve that looks good, but it's going to depend just on 2 points, not on every point like we did before. So let's give that a go on the spreadsheet. Try and do regressed version of the curve, but using 2 points on the line. So probably what I should do is work out different k values for different points on the line. First of all, I'll set my point for C, which is my asymptote. So we set that at 10 last time, so let's set it at 10. I need to work out a point to use. So which point am I going to use? Well, let's use the third point. Let's see what that looks like. The point when x equals 3. And then we need to work out our a value. Our a value is basically the first value because that's where it crosses the y-axis. Subtract, oops, again, and that equals this value subtract whatever the asymptote is. And And so now we should use a k value we'll put in there later. Let's work out our k values. Well, I can't work out a k value for 0. I need to use 2 points. And actually, I need to work it out. It's going to be, what we worked out before, it's going to be 1 over x. I'll make the whole thing open brackets. So I'll put the other on something, then log of. And now we need y subtract c. That's my y value. Subtract c. Divided by, actually I need to click there and make another bracket in here. Get another bracket in there. Because inside this I'm going to do a fraction, which is difficult to do, so I have to do something divided by something else. And now we need divided by a, which is this one. So I've got a bracket there, divided by a. Close brackets. And then this is now, it's done the log of this whole thing. Close those brackets, and now the log of the whole thing. And it's divided by x, because it's 1 over x times that. So divided by the x value here. And the x value can change as we go down. The f3 is the a value, doesn't change, so lock it. f1 is my asymptote, the c value doesn't change. b3 changes because it's the y value. And let's copy that down. These different values of k we get, we should see they're pretty similar to the ones we got before, which was negative 0.189 when we did the regression. So there's one that's really close. We did the regression using the whole line. And now we need to do here, this is a bit of a strange command, but it's equals offset. Offset looks a certain number of points down a column or along a row. So I'm going to start off from this point here to do a k value. It would be comma if you do it in English, but I'm doing semicolon because mine's in French. Offset that, and I need to go 3 rows down because that takes me 3. So that value is how many rows down to go. And then no rows, no columns across. And I need to take 1 row and 1 column of data because I only want 1 value. And that should give me now my k value there is 1, 2, 3 further down, and that's what I pointed out to. So that's got my k value, and if I change that to 4, it changes to the 4th value down. If I change to 1, it changes to the 1st value down. So now what we need to do is calculate the actual regress line, which is equals a times the e to the power, which exp is e to the power in spreadsheets, k times x, so it's k times x, and this is my x value, those brackets, because that's the end of my exponent, plus the c value. I need to lock f1, so the c value doesn't change as we go down. And a2 needs to change as we go down. f4 doesn't change, so that's the k value is the same for everything. And the a value doesn't change either, so we lock that in place. And it fills it down all the way. Yes, let's do that. So this is now my regress line. Let's see what the regress line looks like by selecting the original data points here and the regress line. Insert a graph and see what it looks like. I haven't got the x-axis, so I can't drag that in. I need to put x value in here, my x-axis, and delete it from the y values. And maybe I'll just take the original line, which is the original y values. That's the blue line. And I'll put a point cross on each of those so I can see where those points are. And make the line more dotted and really narrow, so we can't hardly see the line. So these are my original points here. And when we got point 1, you can see the regression line or the regression curve is going through the one at the origin, because we set that one as to give the a value, and then go through the first point there. If I change that to 2, regression line goes to the second point, you can't see a big change. Change to 3, and now this curve goes through the third point, and it should go for the fourth point if I change to 4. And actually, this one is very similar to the regression line we got before. It's pretty much similar to the curve, so I could try different ones. Try 0.5, 0.6. That's lower. That's not very good because it's below most of the points, 0.7, and so on. I keep on trying different values. But actually, 0.4 looked pretty good. It goes pretty much through most of the values, and that's pretty similar to the one we got before, negative 0.189, when we did the regression on it. So it's not a bad equation for the curve. And so now we find, using a good point, we've actually got y equals 82.77 e to the power negative 0.189 x plus 10. If we look at how that one compares to this one, it's got a slightly different initial value because this one goes to the first value, this one doesn't quite. But this one looks pretty similar, and we've got a curve that looks quite good. In theory, this one's better because it looks at all the points, but that's a good one to start with. That's the technique we use in the exam. This is the technique that we can do on top of that to go back and check. That also gives us a Pearson product moment correlation coefficient, so it gets a good idea of whether the actual regression line is correct or not, the regression curve. This one, we have to look at it by eye to see whether it looks good or not.